Yes. Okay. Can I start now?
Yes.
Okay, good. Before starting the presentation about test in RTSM and debug, I would like to show you a new slide that I have added to the presentation of yesterday about a question you ask and about the delivery process. This slide is in the file I sent you to, yesterday. So for RTSM, the delivery process is very, very simple. RTSM is composed of only two Maven artifacts, and they can be delivered with the Maven delivery delivered command. And after you choose the version when you want to deliver, the current version, the hotfix version. So you have a list and you enter the choice. Each part can be delivered individually, of course, but generally, if you modify the API, you also modify the core. So generally, when you deliver API, you would deliver also the core. But in practice, you only deliver core. Be careful when you modify the API part is used by other components like Chameleon and Squirrel. So the modification you have done may have an impact on them and produce an error on them. So be careful. When you deliver a component, you need to put a version. And the rule we have defined in your team, in the Daniel team, is described here. The version is split in three parts. The first part contains is the same as the official OT version, for example 2.3.0 or 2.2.1. The last two digits after is used for the sprint number. For example, sprint 9, or in 2.2.1, actually we are in the MD2 delivery process. On the production choice the number 30. So we take the same number as production team. And the last number in green is incremented each time you need to deliver a binary in this sprint. So normally the number is sufficient. And this rule is the same for all components of Daniel team, but perhaps from a component that have been transferred from other team, the rule is maybe different. And the official version can also be the internal version. For example, 2.3 can be 13. Depends. But we try. You can find the boss case. For the Mercurial branch, the development during the development phase, so before the technical release, we try as much as possible to deliver from the default branch. We don't do a specific branch. But it can happen that validation need a fix. And if you consider that the last version is compatible with the validation team, you can deliver from the default branch. But if the binary is not compatible because the API is different between the two versions, in that case, you need to do a specific branch. But generally, the last one from the default branch is used. After the technical release, so we are in the support phase, and when a hotfix is needed at this moment, we create a specific branch for this version, and this branch is used for deliver all hotfix of this version. For example, actually, in RTSM, we have a branch named OT12, OT11, and OT 2.1.1. You can see we have the internal version and for the old version, the official version. Because the rule, I think, changed around 2.1 or 2.1.1, I don't remember. They introduced the internal version and official version. So it's a little more complex to manage. Because we have two versions for the same. Okay. Is it okay for you for the delivery process?
For me, okay.
Okay.
For me, clear too.
Okay. So normally, for all other components, it is the same. Okay. Perhaps I can do also a quick callback on the architecture or RTSM ecosystem, because it is important for the next part. So, as you remember, RTSM is connected to two kinds of call servers, SIP server and Oxy. Both of these two call servers are device-oriented, and also both SIP server and Oxy provide CSTA events. These CSTA events are directly processed by the RTSM for the SIP server part, but for the Oxy part, the CSTA events are transformed by OTS in a specific OTS protocol based on a SOAP. And RTSM receives this event from the Chameleon events. For the SIP server, RTSM receives the SIP server event directly from the CSTA PSTK binary. So you can see RTSM receives event from the two call server parts and produce RTSM event on Chameleon bus. And the other role of RTSM is to provide telephony service for REST and SOAP. So there is two parts, service and event. RTSM transforms the event received from the call server from a device-oriented model to a user-oriented model. Okay. On the model, of the telephony. It's a user call model. We call it user call model. And a user can have a different call. And a call contains call data, leg associated to the device of the user involved in the call, and participant who correspond to the other user in the call. Okay, so a callback. I keep this line, and I start now the next presentation. Okay. So today we talk about how we do unit test in RTSM, and how we can do debug. We use the standard location for test, the standard Maven location for test. So for test, of course, we write also some code to do test. And the code for doing the test is located in the standard Maven location, source test Java. In order to do test, we have mock. You understand mock? Sorry.
Yep.
Yes. We have mock all RTSM ecosystem for test. So the idea for RTSM test is to run RTSM with all ecosystem with an ecosystem mocked. Tests are based on test ng testing framework, and we use scenario file, and scenario file are text file. The idea is that as you see in the RTSM ecosystem, RTSM receive event from call server from SIP server on Oxy, and the idea is to store this event in a file and inject this event in RTSM. And all these files are, of course, resource of the test, and also located in the standard Maven location, source test resource. These files are, of course, proprietary, but the definition of the event, for the definition of the event, we use XML or YML. It's similar. And the most easy to read is YML. Very easy to read. XML is a little more complicated to read because important information is hidden in the name. I show you a lot of examples after. In practice, but also the main part of RTSM is to handle the telephony event. So tests are mainly based on the event. We can do some simple tests on service but services are generally very simple and consist to call a method on the call server. So it's a direct call and it's very simple. But in some case, before the service call the method on the call server, the service can do a little check if the request is valid or not, and the check is done on the call model, and the call model is updated by event. So generally, when we have a problem on service, the reason is because the model is not up to date. And why the model is not up to date? Because we have a problem on event. So the main part are the event. So test. The focus on test is on the event. A test class is a Java file and contains different scenarios. In the Java file, each scenario is a method, and a scenario corresponds to a telephony use case, a simple call, a transfer, a merge, transfer and merge. So it can be a simple use case, like the simple call, or a little more complex use case like a transfer and a merge, but it can be more and more complex because telephony can be very complex. You can do a lot of things in telephony. So in fact, the RTSM unit test can be considered as component functional test because we don't focus on a small part of the code, but we inject event that can be sent by a call server, and we test all the component part of RTSM, and we check the event that produce RTSM. So RTSM is RTSM unit test is more than unit test. It's a functional test, component functional test. Okay. A test is composed of different files. I'll show you example after. We have a scenario file. The scenario file is under source control and contains the command to execute for running a scenario. And the typical command is to inject an event, like a delivered event, an established event, or a call state event from OTS. And the event is defined in XML format or YML format and contain all attributes that the call server sends. This file is the scenario file. The main, so it is the first entry point of the test. When we execute this scenario, the RTSM test framework produces a result file. So this file is not under source control because this file is generated by the test. and contains the current result of the test. After that, we have a reference file. The reference file is under source control, and content is compared to the result file. So a working test, the content of a result file and reference file are the same. When tests fail, of course, the test framework indicate where you find a difference, but a good practice is also to use a text file comparator to compare the result file and reference file, so you can see where are the differences. The test framework doesn't do a text file. It's not a text file comparison. It is a data model comparison. The test framework for each event creates a data model. A data model is a very simple object composed of 3 elements. For the basic one is like a string to define an attribute, the content of an attribute. After, we have a map for the object. So a map, we have for the key the name of the attribute, and for the value, we have a string. And for a list, we have a list. So we have 3 kinds of objects for the data model. So the test framework compare each attribute. All attributes are compared. And if one is different, the test fails. Of course, the test framework permits, as the test comparison is not based on text file comparison, but on data model, we can define rule for test parameter. Like don't test the content, but only test that there is a content. Or for another case, in telephony, each time you do a call, you have a call identifier, and this call identifier change each time you do a new call. And there is some mechanism in the test to replace this kind of attribute that change in a fixed value. For example, we change the call reference to the value C1 for the first call find in the test, C2 for the second one, etc. More easy after to read, but in the example I show. After that, we have a merged file. This file is not, in fact, I added this file recently because it helps for debug, and it's not generated for all tests. But it's also a generated file, and this file is in fact the content of the scenario and the result file. So you have the first file and the second file in one. And it's more easy to analyze the call flow when you have both input and output call flow in the same file. After, there is a service file. This file is under source control and contains the service to be executed for the test. The service part is very simple because it can be complex to implement this part in the test framework. So we only do a simple way to test service. And the rule to launch a service is based on trigger. And trigger are scheduled on the input event. And when the trigger match, so the service is launched. But we have very little number of tests in service. We try to do one test for each service. If you remember, in RTSM we have simple service and complex service. Simple service can be tested by this way. For complex service, in the majority of cases, we can check them by this way. Too complex to do it, and for only a few requests, so we don't do it. We check complex service on with functional tests and mockup on real mockup. The last file is unique. We have only one for all the tests of a class, and is under source control, and contains in fact it contains the chameleon cache information, and chameleon cache are based on CMS information. In the configuration file, you find the user, some parameter of the user, and the device of the user. Okay. Donc, the unit tests are run by Maven after the compile phase. It's the standard Maven build. If you know Maven, it's executed in the standard Maven build lifecycle. For example, if you do a mvn clean install, you launch the compilation and installation of the RTSM, and it is also launch the test. Because in the Maven build lifecycle, tests are run just after compile phase, and install phase are later. But you can skip them if you want, and to do that, you have only to put the Maven option to skip them. Okay. Unit tests can also be run from Eclipse, of course, and it is very useful for debug, because when you run a test from Eclipse, you can see the trace and use all the power of the Eclipse tool, like you can put a breakpoint, so you can stop the execution of the code. So easy to debug. Some people like to use breakpoints, others prefer to use traces. so as you want, or both. Personally, I prefer traces, but in some cases, breakpoints are useful also. Okay. We see that after in the demo, but for the main class for test are listed here. We have one test classes for test from SIP server. During the Genesis removal, we decide to improve the test framework of RTSM and to use the test done by SIP server. SIP server team write a lot of tests, few hundred of tests, and the idea is to automatically retrieve them. And how we do that? We have done a tool that parse the SIP server log file and create RTSM scenario file. The SIP server is also under Jenkins, and they have a nightly build or daily build. And generally, we take the nightly build, and when SIP server execute test, SIP server produce debug file, and the tool read the debug file from the Jenkins repertory and create scenario file. And this scenario file can be executed by RTSM framework test. The idea was to do as less as possible manual operation. So the generated file by the tool is directly used for the test. No manual modification. But sometime when we launch the tool, SIP server have done modification in their test, and as you see previously, the scenario file is under source control. So when we launch the tool updates the file which is under source control. If the update change nothing, so there is no update of the file, but you can find an update on the file, and perhaps the update is not correct because there is a bug in the SIP server. And in that case, we inform SIP server team that this scenario has changed and the new result is not correct. Or it can be correct, it depends. So you need to analyze the change. So SIP server team like this kind of information. because we inform them about the potential bug in their test or in their binary. But as you know, now the focus is not on a CV user, because seed server is for CV user, and the focus is now only on CT user. So during the Genesis removal phase, of course, the tool was launched very often. But now, since the new the new management decision to focus on CT, we stop to launch synchronization on a SIP server file. But perhaps you need to do it. I think the last time is 6 months ago. And of course, SIP servers is also now stable, so they don't change the exiting test. So normally, it's not necessary to do it. So this test class is for all tests about SIP server, and these tests are automatically retrieved from SIP server test. The second test class is for generic test on OpenTouch. So for CT, on CT, on Oxy, CT, CV, on BOSS. And this kind of tests are done by ourselves. So they are not done automatically. We do it manually. Okay? After that, we have test from CR. So each time you have a CR, you can create a specific unit test for this CR. And you can put this test on this file. The next one from QA is now not really used. It's what used at the beginning on the Genesis removal phase, because at this moment we don't have CR. We only have a valid test from QA, and QA write the problem on the Excel file. And, because at the beginning of the project Genesis removal, we do it not on the official branch of OT. We merge after. And of course, after the merge in the official branch, the official CR are done. But before, we have a specific file. So this one is not used now, but it contains tests from the beginning of the Genesis removal project. So the tests are run, but we don't add new tests. So for each test, we have utility. For the form one, I already talked about it. We have a dedicated tool to generate the scenario file. And we have also, for each test class, an utility to generate the configuration. because the configuration is a complex text file, so it's more easy to have a tool to generate it. Okay, I show you example after. Okay, this slide summarize is a summary of the previous slide in a graphical way. The component to test is the RTSM. So this component is not mock. We try as much as possible to call RTSM without modify it. We directly call the method of RTSM directly. So the test framework architecture of RTSM is consists to mock all the components in the ecosystem and to introduce a module scenario executor to execute and check and read also. So the scenario executor read the configuration file and check the result. You can find that we have a mock for Chameleon Event Bus. We have a mock for the cache, the Chameleon cache part. You find all the input or output file. The configuration file is read and injected in Chameleon cache mock and used by RTSM to retrieve the device or inject a cache event. The scenario file read by the scenario executor, but the scenario file can be generated automatically from SIP server log, as I described before, or from RTSM log. On the RTSM log, you can find the OTS and SIP server event. In SIP server, you have only SIP server event. For the transformation here, there is a tool, a graphical tool. I show you it. I show you it after. The scenario file is injected by the scenario executor, and the scenario executor injects if the current event is a CSTA event, the scenario executor injects the CSTA event in the CSTA client mock, or if the event is an OTS event, the scenario executor injects the OTS event in the Chameleon Event Bus mock. So after that, the RTSM can receive the event and process it. And after RTSM process the event, RTSM produce an RTSM event. This RTSM event is pushed on the Chameleon Event Bus, but as we have mocked it, we can retrieve this event and do a check with the reference file. At the same time, the scenario executor can produce an HTML documentation. If you remember, I showed you yesterday an example, but I show you again today. The scenario executor can also read a service file and execute the service inside it. Okay, so you retrieve here the scenario, the RTSM ecosystem, but all components are mocked except the RTSM, which is the component we want to test. Alors, okay, RTSM unit test can be handwritten, but it is very complex. So in practice, it is done by a tool and from debug file. I already talked about the first part. For the SIP server test on Jenkins, we have a specific tool for the scenario creation file. And for all the other parts, we have a tool, Hippolyte. Hippolyte is a graphical tool that can parse SIP server call file, RTSM call file, and it can also parse other debug files like THS, OTS, and there is no limit. The limit is what we implement in the tool. But the tool is dedicated for telephony. I also use this tool for debug and for CR analysis. For example, when you have a CR, you can quickly analyze the debug file with the tool, and you can see if the call server input call flow of RTSM is correct or not. If the call flow is correct, you can describe if the call flow is correct, but the RTSM output is not correct. The RTSM, with the Hippolyte tool, you can automatically, by a simple click, create the scenario file from the wrong use case, and you can create a unit test for test and correction. So automatically, you create a unit test for a CR. And this unit test is used for correct the correction and for regression, to avoid regression. There is only two kinds of files that can be used for creating a scenario. The SIP server log file for the CV user. The SIP server debug log file contains XML, testr event, and service. And these XML events are used to create the scenario. But the most interesting log file is the RTSM debug file, because in the RTSM debug file, you have both of the call flow. You have the CT and CV part. For CT, you have the OTS event, and for CV, you have the SIP server event. In practice, as unit tests can be handwritten, but it is complex. In practice, the first time you execute a scenario, the test framework produces a result file. And of course, the first time there is no reference. So the test framework produces an error missing reference file. But the easy way is to check if the content of the result file is correct. So you need to read all the result file. And if the result file is correct, the only thing you have to do is to rename the result file to a reference file. And for the next execution, if the result change, the test framework generates an error. The error can be correct. Sometimes it be correct because so in that case you can update the reference file, but sometimes the error is a true error, and in that case you need to find why there is a change and correct it in the code. And of course this part is manually. Okay. This is the last slide. After this slide, I do some demo about all of I talk before. For the Maven, the tool, the scenario executor is included in a jar file. And at the beginning, I think that this kind of test can be shared, so it's not directly included in RTSM, but in another repository. It can be used by other components, but in practice, only RTSM uses it. So in the Chameleon Infra Tool repository, you have a lot of tools. On the first one, JSON scenario, is a folder where you can find the scenario executor. And you can find in this folder, so of course the scenario parser, the data model comparator, and also YML utility. You know what is YML?
Yet another
Yes.
markup language.
Sorry? You know it? No? Okay.
No.
No. I show you. It's like XML. You know XML?
Yes. Yes.
You know JSON?
Yes.
Yes. But YML is same, but more simple. In fact, the most complicated is XML. XML is complex to read. JSON is more easy to read, and YML is more easy to read than JSON. So if you put in order an order of what is most easy to read, the most easy to read is the YML format. After you find JSON, and at the end you find XML. YML is very to read. So in JSON scenario part, you find the different utility. And also you can convert YAML format to data model from YAML from text file to YAML, so you have different utilities. In the Chameleon Affront tool, you can also find the Polit graphical tool. The JSON scenario is only a library, so it's not directly. It cannot be used alone, and it's used by a dependency in the RTSM test. It's also used. I don't remember. I think it's also used as a dependency in the Hippolyte tool. And like any Maven project, you can find the binary under Nexus. Or of course, if you build the component, you have also the binary. There is no official build of the Hippolyte tool. So there is no branch, only the default branch. Hippolyte is an internal tool. Normally I present this tool to the OT front end. So sometimes front end, OpenTouch front end use this tool to help in log file analysis. Okay, so that's all for the slide presentation. Now I start demonstration. But perhaps you have some question before? Or you wait the demonstration?
Yes.
Okay. Okay, demonstration. You see the
Yes.
the Eclipse shell, okay? So I have a project for RTSM. RTSM, so tests are located on core source test. And you can find here some files that I distributed to you before. The first one, in fact, play scenario is an initial tool created at the beginning because tests are launched at the beginning of the RTSM project. Tests are launched manually, but we improve the test, and now all tests are automatically launched. So I don't use this tool from many years ago. So the compilation is still okay, but we don't use it. After, we have also some standard unit tests. So standard unit tests are Java code tests, but they are limited to a small part of code. So we have, but we try. It's more easy to use tests based on scenario. We have some tests on capability. So this kind of test is only Java code. And here we use EasyMock. It's a test framework tool. we don't, in practice, we don't add a test now in this kind of class. So we have a specific test for leg capability. Another one also in Java. So true unit test for testing the STR requesting manager. After that, you find the different class for test about the scenario. And a test is very simple, only one line, and consists to call the method execute on the scenario file. And of course, there is a lot of code. There is a lot of code under the execute method, but is RTSM unit test framework. When you need to add a test, you only need to add a Java method with one line. On the line, call the method execute and contains the name of the scenario file. That's all. So in Java code, adding a test, it is very simple. So you have same for CR, QA, zip server. Test load is a Java test that I wrote during the Genesis removal phase for test the RTSM in traffic by simulating. I use the RTSM ecosystem mocked and I inject a lot of event. I inject a lot of event, and in order to calculate the number of events that RTSM can handle in 1 second. To have an idea if we take a lot of time in some part of code. And the conclusion was we take a lot of time during the transformation of XML to Java. And this part is done by the CSTA component, CSTA PSDK component. On the ratio is around 1. For example, in 5 seconds, you take 4 seconds to decode XML to Java, and 1 second for Java RTSM specific part. A lot of difference. After you have OT test, and Oxy test are specific for Roxy. So as you know, Roxy is in standby and is not an OT part in OT. Roxy, in fact, is the idea is to provide a REST API for Roxy with a very simple server. And in this case, we suppress a lot of components in order to do a very small server. And in Roxy case, RTSM is directly connected to Oxy. And the last tests are also based on Java. And I added this test in the last version in OT 13 for the multi-device, the new feature multi-device. Because in the last version of OpenTouch, we add the multi-device on the CT user, and we have also improved the way of computing the switch device capability. Now we are near of what we can really do, because before the switch device capability was only based on the rule if a device is free device is available or not. The previous rule was very simple, but now the rule is very complex and based on the type of the device, the number of calls on the device. It's very complex. So in order to handle all the case, there is a specific procedure to compute the switch device capability, and this class is used to test all the case. But it was complex to do it with scenario, because there is a lot of case, and it can be difficult to produce a specific scenario. So the idea was to simulate the different use case, but by setting the RTSM model in an initial state, and after that we check if the switch capability is available or not. So each test consists first to set a specific state in RTSM model, and after that we check the switch device status. So we have different tests. Okay. Okay. And I show you now the scenario file. So for example, if the most interesting now is a test OT, because the test from SIP server, we don't focus on this part now. So interesting are test OT. So we have some tests on the scenario file. So each test is a file. And the scenario file are located here. So we go to core, source, test, resource. In the root folder of resource, you can find the different configuration files for each test: TR test, OT test, OXI test, validation QA, validation test. You find the relation. You have the same name after config on SIP server for SIP server. So if I open the config OT file, you find the description of a user, so the category of user, the phone number, the different device associated to the user, and different parameters, all times the same. At the beginning, you have a summary what is the content of the configuration file. As you can see, it can be complex to write this kind of file. So there is an utility. On utility, in fact, tool are located in the tool package. And for OT, you have the OT config wrapper. And here it's more easy to add a new user because for example, if you want to create a city user, you only need to set the OTS node a number, and if you have a different user, you have a specific method to add a device. So it's more simple because all the time we have the same configuration for all the users. And the only part that change is the number of the user and the device number of each device. Okay. You have the same for all things here. Okay, for utility. You also find for TestNG the test suite description. So you can find here all the class used for test that are executed when you launch the Maven compilation command. After that, you have a folder for each case. So for the SIP server, you have a folder for SIP server, a folder for OT, a folder for CR, etc. For SIP server, when you open the folder, you will find here all the files. There is a lot of scenario. If I open a simple call test, so the input is the scenario file. In the scenario file, you find a summary of the event sent by the SIP server. So you can quickly see that this device call this device, answer, and release. So you can quickly identify what is done on the scenario. But it's also described in the name. But the name are retrieved from SIP server team. We have the same name and the same number that SIP server team test. After that, you find specific command for SIP server. If you remember, for SIP server, RTSM need to monitor. And these commands are used to simulate the monitor. And after that, you find the event that SIP server send to RTSM. The command to send a CSTA event is CSTA event. And after that, you have the device on a number for this event. Interesting is, of course, the content of the event. So in the scenario file, you find all the events. When you execute this scenario, the test framework produces a result file. Result file. In the result file, you retrieve a table about the input scenario and the event generated by RTSM. And if you remember, yesterday I present you an HTML documentation with a specific notation, L for leg, P for participant, plus for added, minus for remove, and for modify, and we retrieve this notation here. So we can quickly see when a leg is modified, like here, when a participant is removed, like here, and you find after the event produced by RTSM. And here we have a specific command because here we don't inject the event, but we check the event. When the test framework processes this command, it takes from the chameleon event bus mock an event. If there is no event, the event framework produces an error because you try to check an event, but there is no event, so it's an error. Normally, you have an event, and the test framework takes this event and compare to the reference here. And the comparison is done on all attributes. One difference, test fail. If you want to remove a test on an attribute, you remove the line. Only attributes present here are tested. For example, if you want to remove the test on cause, you remove the cause on the reference file. For call reference, normally call reference is a string composed of 16 digits. Or 8 bytes, as you want. But it is complex to identify two values, and the value can change. So there is a utility to simplify the string to another one more easy to read. For example, G1. In fact, when we find a call reference, the first time we put it in a map associated to the value G1. The second one, we add it to the map with the value J2, etc., etc. And each time we find the call reference, we replace it with the value in the map. So, as you can see, there is a lot of attributes that are compared. All attributes are compared. Okay, I don't show you, of course, all of the tests. So result and reference are the same. Because if you remember, the simple way to do a reference file is to rename a result file as reference file. So content are the same. Sorry, that association. Reference file. Same content. Donc, in the scenario test, you can see the input are XML because the input are taken from SIP server test and SIP server produce XML. And this event are taken from SIP server debug file. Okay, but the reference in the reference the format is YML, and you can see it is very easy to read. You only have like JSON, the name of the attribute and the value. And the important in YAML is the space, the number of space at the beginning of the line. When you have a space, it indicates a new object. And for list, you have the minus thing for each item. In XML, it's a little more complex because the useful information is here, and you have a lot of noise around the value. And YML is more compact. This is the reason why I choose YML. Okay. For OTS, you can find OTS test in the OT folder. We have 3 folders. One for test only for city user. One for CV user only. And the last one, enter up, for tests that involve city and CV user at the same time. For a city test, for example, the simple call case, same as SIP server test, you find the input event, but in OTS, the name of the event is all the time the same. It's a call state event. We don't have a lot of information here. And you find in YML format the OTS event. This is OTS event, if you remember, is retrieved from the OTS driver. OTS send an event in SOAP to OTS driver. OTS driver create from this SOAP event a chameleon event in Java and push it to the chameleon event bus. And RTSM receive this event in Java, and we transform this event in YML. This event is available in the RTSM debug trace and is used to create a scenario or debug. The name are same. Normally, the name are the same as in the OTS SOAP event. The name of each attribute. You find the call identifier, OTS call identifier, the global call identifier, the number correspond to the other party, the capability about the call, the state of the call, the cause, OTS event. So for a CT scenario, in the scenario file, you find all the OTS events about this scenario. In the result, the result file, we retrieve the input event from RTSM, but we add a useful information because this file is generated by the test framework. So the test has been processed by the test framework. On the test framework, we add an information to help to understand the scenario. We add the state because all the time we have a call state event, and call state event indicate nothing. The interesting in the call state event is the state, and of course the number of calls. But we can add a lot of information here. We try to limit in order to understand quickly the telephony use case. On the state, it's sufficient. You can see yelling state. So 20 0 call 21, 21 ring, 20 0 go to the ringing outgoing state, 21 answer, and 21 release, and 20 0 go to the ringing state and release. So you can easily understand the telephony scenario. After that, as same as the SIP server, you find the event generated by RTSM and the full content of each event. And these events are compared with the reference. And same as before, the test framework do the same for all kind of scenario tests. All attributes are checked. Okay, now I run the test for OT. So to run test from Eclipse, very simple. You run as TestNG test. So TestNG call all the methods in these classes, and the test framework produce all results and compare each result to reference file. Okay, it take a few seconds, and you can see the trace produced. Okay, I think. Okay. Okay, test finished. We have run 100 tests. All are okay. If you look at the console information, there is some statistic about test. So we have executed 100 tests. The scenario executor have compared this number, you see it, to around 2000 events. So you can see there is a lot of objects that have been compared, and you have also statistics about number of files of attributes that have been compared. So you can see there is a lot. For example, I don't do it now because it take a long it take more time. I have executed all tests and I can show you the result for all tests. For all tests, this is the number of tests if we execute all. This is the number of objects that have been compared and the number of attributes compared. And you can see there is a big number. Only for information. So, okay. Okay. You have some question?
No.
No. You understand not how we do test the scenario mechanism?
Yes, it's clear, but I think we should play with the tests.
Yes, okay.
And come back with questions.
Okay. Perhaps one thing that I can do, it's not correct to do it. I introduce a bug in the code to show you what happens. Of course, it's not correct to do that, but it's for educational purpose. Okay. And it's, by the way, I can show you the RTSM code. If you remember the package, we have command part and OT part. In OT, you can find package specific for the call server. And for the demo, I show you the OTS part. The entry point for the OTS event is the OTS event receiver. And the method that is called when we receive an OTS call state event, the main event from OTS, is onReceive OTS call state event.
Почему?
So this function is the main entry point for OTS event. At the beginning of this function, you can find a very important trace, because this trace dump the OTS event, and this trace is used, I show you by a demo after, by the ePoly tool to generate and create, or to create scenario. Normally, okay, so done. You have here the method print dump in YML the event. Okay, so after that we receive a list of calls from OTS, so there is a loop on it. Okay, if you remember tip and tricks, if the call server tip if the call server tip of the global call identifier, OTS provides a call reference. Call reference is extracted from the global call identifier provided by OTS. Okay, on server tip reference value. And if the server type is 4, we do nothing. We do nothing. So the even is high. Okay, but of course I don't explain you all the code, but I want to introduce a bug. In simple case, for example, I can introduce a simple bug. Yes, I put this line in comment. So I remove yes. Switch device. I remove a line of code. Okay, and I rerun test. This code, in fact, I put in comment a part of code about the switch device capability. And this part of code is used to remove the capability switch device in conference, because on Oxy, when you are in conference, you can do nothing. So we identify this case by the code, conferences, and we force the switch device capability to false. So you can see we have run the 100 test, but one failure. If you look, one is red, and you have an exception, and the exception is we accept the expected value is dropped, but we have drop on switch device. And it's normal, we have removed the code that remove the switch device capability. So the switch device capability is added, but it's not correct. In reference, we don't have the switch device capability. So the test failed. Another way to find the difference is to use a text file comparator. Text file comparator. Okay, and to compare the result file with the reference file. So the test file is ICM coloxy. So one difficulty is to find the file because there is a lot of files. So file, all test files are in the resource folder. So we execute an OT test on Oxy test. Yes, Oxy test. On Oxy. No. Where is the test? No, ICM Oxy. I'm not here. Perhaps here. Can't find. The most difficult is to find the file. Sorry. ICM call Oxy, ICM call Oxy merge. Okay. I find. So I take the reference file. Okay. the result on reference file. Okay, and I show you now. I use axis merge tool to compare file, and you can see on left there is the result file, and on the right there is the reference file. And if you compare the file, there is a difference here, because in the result file we have the switch device capability, but in the reference file the switch device capability is not present. Okay, and of course, only for information, RTSM produce a call-ended event, but this event is not used. In fact, for RT 2.0, Eve try to simplify call log, and the call log was computed in RTSM by generating a specific event at the end of call, but we never continue on that one. So this event is not used. The event is generated by RTSM, but not used. Okay, so difference are only on that. Okay, that display name aussi. Okay. Check event. There is one difference here, but there is no check on call-ended events. They have been disabled. Okay. So probably the reference, there is no name. So as there is no check, you can find some difference, but it's not used, and probably never used. Okay, so the only important difference is about the switch device capability. So another way to identify where there is a difference by a text file comparator. Or the error may be sufficient. Of course, I remove the bug, else you need to correct it. Okay. No save. Okay, one way. You can, of course, execute only one test. For example, I execute the fail test, but I still have the bug. Probably. Oh, strange. I have removed perhaps Eclipse. I force the compilation. Project build clean. Alors, je force RTSM build. Okay, and I run the test. Oh, still here. Exit drop. Oh, I have introduced a bug. The file of the team evert. Okay. I probably don't remove correctly the bug. I rerun. Okay, it's okay now. Good. So you can execute one by one a test. Of course, I don't show this part, but you can put breakpoint in the code when you run test. But when you put breakpoint, generally it is useful when you execute one by one the test, because you want to run a specific test because there is a bug in this specific test. I show you now a very interesting tool that I write some time ago, perhaps just before Genesis removal, and I improve this tool continuously, and the tool is Hippolyte. Alors, Hippolyte, you can find it if you compile it, of course, but if you don't want to compile it, you find it on Nexus. To launch it, you simply launch the run. The run, it is a Java tool, so you need to have JDK or GRE installed. This tool can read debug file. So I launch one test, I copy the trace, and in the tool I paste. The role of the tool is to help debug or development. It can also be used for development. And he read debug file. The tool parse the debug file and identify the interesting key. Keys are located on the left. Keys are defined in the tool, and key can be a call identifier, a device, a login, and it's unrecognized key. For the call key, you find the global call identifier, but you can also find the OTS call identifier. And here you find also call see, yes, SIP server call ID. You can select one by one, or you can do multiple selection. If I select, for example, a call, on the right, the tool shows all the event name, and the event name are arranged in a table for each device. So you can simply see each event for each device on the order of this event. You can put color. The tool identifies the different kind of event. And for example, if for sister events are for SIP server event. SIP server, I choose blue. RTSM event, I choose, for example, red. On OTS event, pink. So automatically you can quickly identify the different kinds of events. If you select a line in the table, you have the full content of the event. And the tool focus on the key. So you have a specific color for the identified key by the tool. If you see a key with the black color or the default color, that means the tool doesn't identify that key. So perhaps it's a narration to do in the tool, or a bug in the tool. So you can see the input event from SIP server in blue, and in red, the event generated by RTSM. So you can quickly look if the input events are correct. Of course, you need to read all the attributes. If the input events are correct, you look at the event generated by RTSM. And if there is a bug, you can save a scenario and use unit test mechanism that I described you before. And how you create scenario, very simple. You click on the right button on mouse and have save scenario for RTSM. The tool saves only the output event because the output events are generated. And it is your responsibility to check that the result file produced is correct.
Welcome to the Alcatel-Lucent Conference Center. At any time, you may press the pound key twice for a list of options.
У тебя звук есть? Звук есть? Ну, тишина.
Совсем тишина.
Меня-то слышно?
Слышно.
Ребята, слышно?
Слава богу.